my OR mapping from these 5 product tables, product and order and customer tables from Northwind. And you've already seen me create these mapping files in the first 3 videos, so I'm going to close this for now. And also I've created my typical demo scenario. I have 3 buttons and a data grid. We're going to start first by coming up with a scenario that I thought would be interesting. We want to query the database to find what I call the lame products, the ones that are, say, expensive and they're not selling very well. And so to illustrate the connections between Linq and actual SQL, I worked backwards this time. I actually wrote some SQL Server T-SQL code, and this is it. Let me run it and then I'll explain it. This finds in the product table all the products that have sold over the past year or in history fewer than 200 items, and they cost more than $15. And we see we have 3 products, 9, 15, and 37. What I want to do programmatically is to duplicate this query and then set the reorder level of all 3 of these to 0. So we don't order these products. They're kind of lame. They're not selling well. So let's go map this query to Linq. So back here in my code, I need to, like always, create an instance of my Northwind data context. Let's gather the results in a variable R from the products here. And I want to find all the ones where the unit price was greater than $15 and the order details, the sum of all the quantity. I'll explain this. Let me type it. Fewer than 200. So remember, there's a one-to-many relationships between products and the order details. And there's an order detail for every order for a collection of products. And I want to sum up for every product the total quantity ever sold and find the ones that have sold fewer than 200 over the lifetime of the product. And if it's less than 15, return those products. And I'm expecting to get 3 results since that's what we had before. And we can double check that by binding it to my grid view, which is just a handy way to do some debugging, and data bind it and run. And when I hit the lame button, I find 3 results. Good. So we're halfway there. Now the goal next is I want to update this result set and set the reorder level to 0. We don't want to order these products anymore, so let's 0 that out so we can sell what we have and continue. So to do that, I can loop over using this for each statement for every product P in the result set R, simply loop through and set the reorder level equal to 0. Now, since I've made changes to this result set, I want to save it back to the database, so I have to remember to submit changes. I've done this before where you forget this line, the results would be correct, but the changes aren't saved in the database. Now, we're going to prove that this worked in just a second by running the query, but first I can run it here locally. And now this record set shows the reorder level has now been set to 0. And if we go back to our query and rerun this, that reorder level also goes to 0. Pretty cool. Now, notice, though, there was one product, number 9, the order level was already set to 0. I've had this SQL Server profiler going the whole time, and here's the trace statement for what we just did. That query right there is the one that we ran, that I typed in manually. But see these right here? These are the 2 update statements that were fired through the through our mapping layer, through the northwinds.dbml file. Notice there are only 2 update statements, one for product ID number 15 and one for 37. Again, that's because it didn't need to change number 9 because the reorder level was already 0. So that's a pretty nice optimization. Also note that we're passing in everything that has to do with this item in the product table. Not only the product ID and the changes we made to the reorder level, but the unit price, the description, everything. And the reason why is that because of the support for optimistic concurrency inside Linq to SQL, it assumes or presumes that that record has not changed. And the only way to know that someone else has not changed it is to do a column-by-column validation on every column. And if there's no match, it means there's been a change, no records were affected, and the code behind the scenes would throw an exception. That's the optimistic concurrency. So it's pretty nicely locked down, and it provides you an easy way to detect that if there's a change. If one of these throws an exception, because the entire process behind the scenes here in the submit changes is wrapped in a transaction, everything rolls back. So it's a great little architecture. I'm going to show you some more. Let me show you a little bit more about the transaction concept. Let's do something a bit more drastic. Instead of just setting the reorder level to 0. Let's delete these because, like I said, we're not going to reorder them anymore. So one way to do that is to use the delete all on submit, and we'll delete everything in R, submit the changes, and we're good. Now, because I don't want to actually destroy these records in the database, I want to see what happens if we were to do this, but then roll all this back by wrapping this submit changes in my own transaction. So the way to do that, and again, I'm just trying to illustrate a point here, but it's kind of a cool demo. Let's add a reference to the system.transactions right there. And around this body of code, I'm going to stick in a using statement. I want a transaction scope. And by the way, did you see that? This is cool. When I hit E, that little underline right there, it knows that that's not part of my using statement. If I hit Control period, that's the shortcut for either bringing in the using statement or giving it the full scope. So I'll just bring in the using statement. Transaction scope, TS equals new transaction scope. And then wrap all this in my using statement. And at the very end, I'll just roll the whole thing back using the current transaction. So what's nice about this, I can set the breakpoint here. Let's go back and check my query, run it, just to verify that there's nothing up my sleeve. Those 3 records are there. Now when I run this, I'll hit the breakpoint. The records are now deleted inside of this current transaction scope, but I haven't rolled it back yet. But as far as the database goes, if I run this query again, it's blocked. See, the query that's executing right now is blocked because I haven't enabled a special feature that allows me to read dirty records from the database. So I do that by changing the transaction isolation level to read uncommitted. Now I can read those records, and for all intents and purposes, they're gone. So if I continue this, go back, roll back my transaction, even though this page shows that they were deleted because I'm using this binding to the same record set. If I go back here, there they are. Pretty cool trick. I love transactions. Lots of fun. All right. We've updated and deleted some records in the product table. Let's show what it looks like to create a new one. Let me grab the data context line since I'm tired of typing that. Create a record set from the, well, what do I want to do? Look at my notes here. No, I don't want that. I want to create a new product. Yeah. So we have an instance of a new product that's not in the database yet. I mean, essentially, I create a new product and then just throw it in the database. I'll insert it on submit. But I haven't done anything to the product table yet. I mean, I can go and set any property I want, like unit price. I'll set it equal to a negative $4.30. And it's a money type, so I have to put the M. And then submit changes. Now, this should not be valid. Let's just see what happens. Assuming I spelled it correctly. Insert, oh, not all, just insert on submit, since I only have one. Try that again. Submit the new product, and we catch an exception. So the first one says we can't put, the product name does not allow a null value. Now, what's nice is it's catching this on the code side before I get to the database. It's, let me stop this, stop debugging. If we go and look at the schema for the product table, right here, and okay, so here's the transact SQL, the code behind the scene that created the product table. You can see that the product name is not allowed to be null. Well, that's nice. In fact, there's the unit price. You can see that it's a money data type, and that's been translated into the code behind the scenes in, let me find it, in my database mapping file down here. If I search for, oh, it's so hard to do this, guys, in this small resolution. Let's see. Bear with me there. Class. Where's that? Okay, the product class. So in here, you can see which ones are allowed to be nullable, which ones are not. There's a unit price, which is a decimal. So we get some nice little type checking. So in order to pass this one, let's see, it complained that the full name, the product name can't be null, so I'll call it delete me since I want to remove it later. If I continue, here's the other problem. So we have another constraint. This time, this one was caught on the database. The product's unit price, it can't be null as well, or can't be empty. So we're getting some nice checking. I think to finally get this to pass muster, I think those 2 lines will handle it. Oh, good. So we added that new product in the database. Let's go and blow it away before I forget. It should be the last one in the database. Yeah, there it is, 131. So I'll delete it. Cool. That from products there. Okay. I could have done it in Linq, sure. That's cool. I like them both. Good. So we've added a new product. Now that's kind of a simple example. I have a much more complex example that does a few more things, and I have it on the clipboard. So I pasted it in. We'll walk you through it. We're placing an order for the customer Alfred, whose company name starts with Alfred, and he's ordering both chai and tofu, 22 units of chai, 33 of tofu. And notice this code is actually quite readable. We first locate from the products table the chai and tofu items, and notice the keyword single here. This must find exactly 1. If it finds 0 or more than 1, an exception will be thrown. Create an instance of an order. We have an order date. The required date is in the future. We set the freight, create a couple of line items, and then add those to the order detail. Finally, go look up the customer. We're adding the order to the customer. So this is pretty readable. I mean, the code for this in SQL, I should have written it. It would be a lot more verbose and not as interesting. Plus, we'd have to track the primary keys, the auto incrementing keys, and that's kind of difficult to do. So we're doing a lot and at a level here with Linq that's very readable. So let's run it. The query to make sure this worked, I already wrote it, is right. No, that's not it. Oh, there it is. Okay, I already had it up. So this finds all the customer orders for Alfred's, which is his customer ID is Alfke, and you can see that this database is quite old. Northwinds has been around since looks like 97, and here we are in 2007. So when we run this, we expect to see a new order added for this customer with a date of around today. So we just added that. I've got to kill this profiler. I keep clicking on it. Jeez. Okay. Back here, run it. And there we go. Why is that not ordered by date descending? Ah, well. Oh, it's because I have this cast junk on here. Well, that's it. It's 2007, November 15th. And this order was just added, so that worked. Now, let me break this. I want to show you an example of schema validation. Well, I showed you that before. I want to go a bit farther and show custom property validation, so any individual column, and some kind of object validation overall. And I'll create 2 rules, one that disallows negative freight, so negative charge, and also one that disallows the required date to be before the order date. So to do that, because we're using partial classes, this is actually quite easy. I need to add, using my limited real estate, a new class, and I need to give it the same name since we're dealing here with orders. So a new order class, and this is now a partial class because we're dealing with the order class that already exists down here inside the Northwind Designer. Here we go, Northwind Designer. Oops, I'll show you. There it is. So it's partial class. So we are extending it by adding, which one? The on freight changing. And notice it is a nullable type given the question mark. So nulls are okay, but let's not ship anything for free. So, or us lose money. So if anything is less than $0, then we'll throw a new exception. We'll use it. Well, that's fine. We'll throw an exception. No free shipping. Yeah, I can type. And we'll add one more. So that's when this property is being changed. Oh, geez, believe it or not, I don't remember my keyboard mapping to go to the definition. Go to references. Jeez. Okay, so you can see back here in the partial class that has the implementation for freight on a set. First, it calls on freight changing, and then it sends a property changing notification, and then tells us it's changed. So there's a lot going on here that you can hook into, and we're going to catch it right here by throwing that exception. We're going to do something similar by getting the partial on validate. So this is an overall higher level action. So this is at the very end. Once we've gone through each property, this is now validating the object itself. If the required date for shipping is less than the order date, then we're going to have problems fulfilling that shipping request because we can't go back in time. So let's throw an exception. Time travel not possible yet. All right, so let's try to purposely break our order to make these exceptions be caught. And I'll do that by having a negative freight charge here, and I'll make this a negative days that we're adding to our order. We'll catch one at a time. There we go. No free shipping was caught. So we can fix that by making that a positive value. And finally, we'll catch the object validation. Hey, Ben, come on in. I'm just recording. It's...
Can I run your computer?
What?
Can I run your computer?
Yes, you may go on my computer.
Why does it sound like that?
It's because this is a soundproof room, and it's got interesting acoustics.
That's why whenever you make your videos, it sounds like that.
Yeah, it makes me sound a lot cooler.
Yeah, it does.
Okay, go out and let me finish. I just caught an exception. Thank you. And here's our second exception. Okay, good. So we've covered quite a bit here in this little demo. We've gotten the some interesting insert, update, and deletes. We have some nice cross-table relationship support that's built into Linq. We've got custom schema validation, custom property and object validation, and the optimistic concurrency that lurks between or underneath everything